Thank you, gentlemen. Moving on to the data cloud use case. Data clouds need service delivery velocity, the need to change performance, the need to rebalance, and the need to efficiently share data. Most big data and analytic applications need cross-sectional I/O bandwidth more than IOPS. The Datera QoS bandwidth controls come in handy here. With the ability to promote or demote volumes between multiple media tiers, between all-flash or hybrid, between single replica or all-flash replicas, and live change of QoS parameters, Datera allows for optimizing appropriate data pipelines. In addition, the ability to clone snapshots and instantaneously mount for access makes it easy for multi-reader applications to get the performance while saving on capacity. Bill, it's time to pull together a data analytics use case. And can you talk about the flexibility as well as the dynamic behavior of the system?
Absolutely. Thank you, Ashok. So what we're going to show today is the Datera system orchestrating a microservices-based analytics environment. The actual infrastructure code was provided by our friends at Comcast as an open source project that integrates Yarn and Spark within a microservices framework so that you can quickly spin up analytic environments. What we have here and what you're looking at is the Datera on the left-hand side and the initial deployment on the right-hand side. You'll notice that the current number of data nodes is equal to 1. What I'm going to do is using this framework, again, open source framework that orchestrates the microservices infrastructure, we're going to ask it to, instead of have 1 node, to make it a total of 5 instances. So in the background, what this is going to do for us is automatically spin up, mount, and join into the HDFS environment 4 additional data nodes. Now, what's important here is that within the HDFS environment, you can manage multi-tenancy through tools such as VMware or OpenStack, which is how our friends at Comcast do it. So I'm going to go ahead and refresh the data node page, and you can see we already have 2 of these containers spun up and ready, joining into the infrastructure. You'll notice now on the Datera side, it's automatically updated our instance count from 49 to 53. So we have our new volumes created, they're provisioned. I'll refresh the Hadoop side one more time, and now you can see we have a total of 5 data nodes executing a single command. It makes the velocity of doing analytics environments much, much faster. Ashok?
Bill, can you show us an example of promotion or demotion of a volume between media tiers?
Absolutely. So what I'm going to do here is show the Datera template system. So normally in a normal system, if you want to make a change to an existing volume or provisioned storage, you need to do each volume at a time. So here we're going to actually use the Datera template. I'm going to scroll down to the HDFS data node template. You'll notice here that we have about 6 provisioned instances. And I'm going to edit the configuration, the policy for those instances. At the moment, you can see it's set for a hybrid storage node. We're going to hit the edit button in the corner, scroll down, and there's actually 3 placement policies presented. We have the all-flash replica, which is what we're trying to do now. We also have this concept of a 1 replica flash, and it's something that's relatively innovative for Datera. What we can do is when we're provisioning the targeted placement of these applications, we can route all the data set to 1 flash node and the replica copies to hybrid nodes. The main benefit of doing this is for economics. So now you have 1 copy of flash, 2 copies of hybrid, and the system can manage that. So I'm going to go ahead and press the Save button here. And now in the background, the Datera system will orchestrate and manage the data placement, move the data from the hybrid systems to the all-flash systems.
That was simple. Great job, Bill.
Thank you.
Thank you, everyone.